4-3. Right angle trigonometry. Can you dig it, sucker? Sometimes. Time to get pumped up. Do a little right angle trigonometry. Sometimes you're feeling like you just can't do it. You're staying up late. You just don't know if you can finish your homework. But I know you can. You just gotta dig down deep and see if you can do it. Today! So, here in 4.3, you're going to have the 6 trig functions. We talked a little bit about sine, cosine, tangent, and its reciprocals, cosecant, secant, and cotangent. This actually you guys have seen a little bit of before. We were talking about our little right triangles. Some of you may remember as SOHCAHTOA. So if we look at this triangle here, what we're going to do is we're going to consider a right triangle. We can't consider any other triangle. You have your angle here, which is called theta, and relative to the angle, your 3 sides of the triangle are your hypotenuse. That is the side that is across from your right angle. That is the longest side of any right triangle. You're going to have the opposite side, and then you're also going to have the adjacent side. So, what we're going to be able to do is we're going to be able to use our hypotenuse, our HYP, our opposite side, and our adjacent side. These will help us find our 6 trig values. So, if we remember back from way back when, sine of theta is equal to your opposite side over your hypotenuse, or something you may remember as so. Okay, there's your sine equals opposite over hypotenuse. Your cosine is equal to your adjacent over your hypotenuse, so you have an A and an H, so we call this ca. And then we also have your tangent, which is your opposite over your adjacent, so we call that TOA. Now, in order to figure out your cosecant, secant, and cotangent, remember those are just your reciprocals, so if you need your cosecant, that is... Just kidding, there's no abbreviation. Oh, bless you.
Thank you.
I think somebody just sneezed out a lung. Alright, if you have your cosecant, you just flip-flop your O and your H. Secant, flip-flop your A and your H. Cotangent, flip-flop your A and your O. Here's just some abbreviations we're going to use. Hopefully you guys know those already. So let's look at our first example. We have this beautiful right triangle that I drew freehand. And what we want to do is we're going to find our 6 trig values. So we're going to start off with our sine of theta. And then we're going to have our cosine of theta. And then you have your tangent of theta. And then we're also going to find their reciprocals. So the cosecant, your secant, and your cotangent. Here's the only problem. We only have 2 of the 3 sides. So what we're going to have to do is we're going to have to do a little something called the Pythagorean theorem. And we're going to find out what this side right here, and this is going to be our adjacent side. This will be our opposite side. This will be our hypotenuse. So in order to figure out your adjacent side, we need to take a 2 squared. Sorry, let me review the Pythagorean theorem. That is, if you have a squared plus b squared equals c squared, and c is always your hypotenuse. So we're going to plug in a 2 for a. It doesn't matter if you plug in the 2 for a or b. And then we're going to have a 4 squared over here. So you get 4 plus b squared equals 16. Subtract the 4 to both sides, you get 12. And if you square root both sides, that's going to give you a radical 12, or what you should really do is make this a 2 radical 3. Do not leave it as a radical 12. But your radical 12 just reduces to the square root of 4 times square root of 3, which is a 2 radical 3. Alright, so for your first example here, for your sine of theta, we just want to find the opposite over your hypotenuse, the so part. So your opposite side is a 2 over your hypotenuse, which would be a 2 over 4, which reduces to a 1/2. Now since we have our sine, we might as well do our cosecant. Cosecant then is just going to be a 2, because you just take your sine and flip it. Now your cosine is going to be the ca part, which is your adjacent over your hypotenuse. So your adjacent side is a 2 radical 3 over a 4, which just reduces to a radical 3 over 2. So then if you find your secant, that's going to be the reciprocal of that, which is a 2 over radical 3. And remember, you don't have to rationalize here. Finally, your tangent, that's your opposite over your adjacent. And you're going to plug in your opposite side, which is a 2, over your adjacent, which is a radical 3. Or if you simplify that, 1 over radical 3, which gives you your cotangent, which would just be a radical 3. So to finalize or summarize this example 1, what you need to do is you need to use the Pythagorean theorem to find your third side. And once you do that, you use SOHCAHTOA to find your 3 main trig identities, and then you just find the reciprocals for their inverse functions. So I hope you enjoyed that example.